Hello. Today is May 1st, 2024. This is working group serving second meeting. Welcome everybody. We have a few items on agenda and it's actually quite packed. So let's get going straight away. I will share my screen. Do you see it?
Yep.
Perfect. So, and before even going into agenda item, I want to reiterate that the main goal for this group is to collect requirements and understand priorities. We have so many things that can be improved and so many long-term ideas that it's really hard to decide which one to tackle first, what's the best way to address them. And that's how when we need everybody to contribute scenarios and some know-hows, ideas. So everything is welcome. If you have ideas, if you want to refine some requirements, please go ahead and all the links in this document, or like if we need to present this links somehow differently, also please let me or any other chairs know. We will be working on that. That said, one of the work streams that we decided to have is DRA use cases. And yesterday was another working group, device management, where we start working, like reviewing this DRA use cases. So the second link is from this from their group. So this is requirements for DRA. They call it prototype because it's next iteration of DRA. And it lists some scenarios that they want to support. And some of the scenarios, if not all of the scenarios, working great for inference workload and for serving workload. So you can read up. So those scenarios, we need to think what kind of scenarios we want to expand for, and that's why like we have another document like working group serving requirements. This is from also device management team asked like every working group to contribute their specific scenarios to look at. And this scenario that is we populated so far with some semblance of priority, like what we want to address soon, what we want to address like less soon. So out of all the scenarios that they plan for prototype, and they have like various scenarios, we want to concentrate on a few of them right now. So this is a subset of those scenarios. I want to go through the subset, and please interrupt me any moment. And if you have any questions, suggestions, once we get through that, I think what I want to get out of it is like some acknowledgement that the scenario seems to be important for this group, and then I will try to find somebody to pair up and start writing down like what exactly like we want, and maybe a little bit like more details on that. So yeah, some scenarios are around hardware failures, when hardware is misbehaving. Customers have very little visibility into that right now through the pods. Like they may have some external monitoring and some other ways to understand what's happening, but it's rarely that customer has very good um, visibility through Kubernetes API. And this is something that we may want to improve. Plus, we want to make sure that we can react on those failures somehow in kubelet. So customers may need to decide how they will need to react on the failures, and maybe even have a class of errors that non-fatal and class of errors that fatal for the workload. Okay, somebody adding more. Okay, it's a little bit of misclassification. I think copy pasting happening. So next one is understanding the hardware. We discussed yesterday that one of the scenario is that like this one. Yeah. By the way, this is a little bit of difference between workgroup serving and workgroup device management. If you look at device management, they have like must-have section and nice-to-have section. So this claims with claims that can be satisfied with different device types. Like let's say you have workload like inference that can run on like you want to run on like A100, but like you'll take another like GPU if it's available. So this kind of prioritization that you want to be able to express for inference workload, it's a nice to have section for DRA right now. And I think we want to put it a little bit higher here. We want to have it.
Well, it's in the nice to have for the prototype. Maybe John, I actually was going to ask you that, John. Like, I was getting
Yeah.
confused by what is in the prototype versus not in the prototype mean.
Okay, I think that this was my personal organizational strategy like a couple of weeks ago. I think that probably this needs to be reorganized into what we plan to deliver in Alpha 131 or try to deliver in Alpha 131. And it's also my arbitrary, well, I wouldn't say arbitrary, it's my guess as so the must have in the prototypes originally was around like where do I think we have the most need for things and where are there are the most questions like we have to sort out and reduce the risk. So I need to understand, I need to communicate with this group and say, hey, here's what the API is going to look like. That's super important to get sorted out right away. An individual feature here or there can be on the bubble of whether we actually delivered or not if the API is right. So like to me, the prototype is really about one, making sure that we fast iterate on the APIs and make sure we get the general shape of the API right. And two, if there's any like algorithmically risky things that we can test out whether they're truly possible. So like the partitioning stuff that Kevin worked on was, we didn't know exactly how we were going to solve that. He's figured out a way to solve it. He's prototyped it, and I'm going to incorporate that in my general prototype. So I think like that was an important thing to suss out. I'm totally open to this. Our categorizations of must-have versus, or even if this being part of the prototype, like to moving the step further to what's going to be an alpha, what are the requirements, what are the features there, and I'm looking to this group for the input of like, no, actually, that's really important that we get in beta in 132, therefore in alpha in 131. That prioritization really doesn't come from device management. It comes from serving and batch and network and other stakeholders. Does that clarify?
Yes, thank you. I was confused and I didn't have a chance to ask yesterday because like every meeting is very packed. So okay, I think it's quite important scenario for us to be able to specify to ask for different claims, and then the result of yesterday conversation, like follow-up questions that resulted in this new item is once we have prioritized list of what can satisfy the claim, then customers may need to know what actual real like runtime device was associated with the pod. So we need somehow kind of downward API or any means to understand where you're running at.
Yeah, so that already was planned to be delivered to the driver, but I think the downward API is necessary to deliver it to the workload.
Yeah, and actually, yeah, we need to have that discussion too. Of we need to, when we describe the scenarios, we need to separate out what are things like this one. Actually, for me, was not like the most important thing. I think it is a consequence of the second one, but it was no one should be able to fundamentally change the cube model without thinking about how downward API would work for it. And I think that then that statement may be too harsh, right? Like, we don't have to do downward API technically. So maybe we also need to, maybe that's more of a list of API review principles of DRA. Like we could move that to a separate discussion of, if it had to fall off the list, would we allow? Would that make sense? And I think
it's a requirement, but what's the priority of that requirement? There's other more
right.
important. Yeah.
Yeah, and it's more of a requirement. Just the downward API would be the answer for like we have not been super successful at downward API, as evidenced by all of the people in the ecosystem still waiting to have C group v2. Or to integrate C group v2 into their hacks for determining how many threads they use in Go or in Java. And so I think this is like top of mind for me because I want to make sure that if we do have scenarios that work with different number of devices, that we really understand as a working group whether the users of the system would actually use downward API, why they would or wouldn't, and can we avoid like if everybody just wants to load up the NVIDIA driver and check the stuff, then this is irrelevant.
Right. If it does discovery on its own, then we don't need it in downward API.
Yeah. And then maybe like I was actually going to ask too, Sergey, on the claims one, we should probably flesh out these scenarios more. So like these are kind of like terse, and I think we're all kind of putting it there. But like, what's I was definitely with the other ones. I was trying to like who and what the core scenario is, and then try to get defensible. I don't think we have to get to that level today. But like when we talk about claims, that's a requirement on DRA, but that's not an end user scenario. We should probably also we should ask ourselves, has anyone actually thought from this serving working group thought about how they would actually use a claim and like looked at the prototype and put the pod claim in the pod YAML and said, I hate this. So I think that feedback is I think we need to be able to be grounded, which is somebody on this side needs to help provide the sniff test of, I could specify the claim this way, but I hate it. That's input, I think, to the prototype.
I've gotten that input already.
Yeah.
So I've gotten input that this will be difficult, right? Which means, okay, maybe we need, the platform administrator might understand how to do this, but a typical workload author wouldn't. And so that'll be important to suss out in the prototype. That means how much do we put in the class, or is there some administrative construct we need that lets one user with all understanding of Kubernetes do that, and the other people just refer to it. But definitely, like, let's not confuse the use case with the implementation. Like, claims are definitely a Kubernetes way of doing things, and it's how we do it, and it's not the requirement. I mean, but still, the requirement is being able to get multiple devices based on some prioritized list.
Is having a UI layer in scope something similar to what IBM folks demonstrated with InstaSlice, where they had admission that translated something simple into the claims in the backend?
Yeah, was it translating resources into something like claims, Mernal?
Yeah.
I mean, John and I had chatted about that a few weeks back. I want to see something like that. I think that is a little bit like the node labels. Like all node labels are per end user APIs for what nodes expose. So you're defining an API by specifying a set of node labels, right? Like keys and values. I think resources allowing platform admins to simplify, I think should be in scope. Maybe we could call that as like, I'll actually just put that under understanding the hardware for now, but a platform admin can represent and maybe this actually, we could put this as a subset of this one. I'll come back and fill out this one, but like I do think, Mernal, like it would be good to capture, like to get somebody to write that down and share it if it's not already shared with DRA.
Okay, all right. I'll get someone to do that. Yeah.
Anyway, yeah, this is an interesting topic. We definitely need to dig into like usability of it as well. And yesterday feedback was from somebody on batch level that this can be taken care of by higher level abstraction, but I think we need to have an DRA because for inference we don't have. I mean, right now we don't have any higher level abstraction that can do like Q or anything. So ideally DRA or like ideally the developer of a pod needs to be able to say. I mean, maybe not pod specifically, but I think pod is like closest to developer, like to explain specification, like what it needs to run in terms of hardware.
Yeah, and I saw Janzin made the comment. This is like at some level, we're kind of applying value judgments, which is we're arguing that everyone having to go have multiple deployments to use two types of hardware. If I think we need to get a little bit more crisp on whether that's acceptable. So in theory, in Cube, we've said if you need to deal with multiple types of hardware, create 2 deployments or 2 stateful sets. And now it's your problem to orchestrate across them, which some people have succeeded at. And then if we were to say, like, if you had to do that for CPUs, no one would have used Cube, right? Like if you had to have one deployment for a workload that had 1 CPU and a workload that wanted 2 CPUs, but we implemented that with Burst. I don't think the use case is exactly identical. So I think this is one that we need to dig in a little bit and provide justification for. But at the heart of it, I think this is enough people have brought up variations of this that this is the strongest one. Faye, I know you're on the call. This was actually one of the ones that I know you hit through Kaito. And so, we had you on the agenda. Like, how painful is this in general in your experience for end users having to deal with this distinction? I know it's something you solved in Kaito directly.
Yeah, so we are talking about can you hear me?
Yes.
Okay, cool. So so this is a very interesting discussion. Talk about the understanding hardware. So that's exactly actually it's not users, trouble. It's our trouble because in Kaito what we do is we try to abstract everything. We just give a user extremely simple UX. Just tell me what model you want to run. Now when we come to the end, so we need to pick up the hardware, then to actually feed the model requirements. Some difficulty that we are facing that apparently the CPU count and the GPU memory is not enough because based on the characteristic how all those large language model was running, there's one thing that is per GPU memory. So that's a key. Because if you don't have that hardware information in mind, you will easily.
You broke up there on the thing that you said was key for me. Could you repeat that?
You're on mute now. Right.
Can you hear me?
Yep.
Yeah. So usually what I mean is that when we have a SKU, so in general, when we SKU, this tell you how many GPU the node has, right? And how many GPU memory the node has. And the GPU memory is an aggregate number. So usually, but what we really tell is on average, each GPU, how many GPU memory that per GPU have. Because usually when we run the model, you will load the entire model into that GPU memory. So by default, if you don't configure it correctly, you will easily hit out of memory, even if you have aggregated GPU memory in the node. So again, this is not a fixed thing because when you play with touch parameters, you can consider how you want to distribute your actually model weights across multiple GPUs. But it's kind of the thing that can easily get wrong, and we need to figure out exactly the requirements, for each model. If you want to use, let's say, pipeline parallelism, what exactly per GPU memory the requirement is. So we have that information in mind because we know the models, because Kaito is using preset. So we only have a bunch of models that we support. So we know exactly for those models how much per GPU memory it requires. Then we got a SKU and we do a math and we do a simple validation check. So to see if that SKU can satisfy that model. So this is the first thing that we see. That's if we don't do this, so customers can easily get it wrong because if they got a SKU, they don't configure touch in the right way, you just hit out of memory in a very strange way. So because they say, oh, I have enough GPU memory, why it doesn't work? So this is just combination of hardware and the way that the framework works. That's a reason. I think that's what Clayton was mentioning, that exactly is like we probably need to have a deeper understanding, not all the hardware. So maybe at least one metrics that I think worth mentioning is a per GPU memory, not exactly aggregated one. So and that's the number one trouble that we were hitting. So that's the second thing that we were debating is that with all current metrics to describe the capability of the GPU, so the only metrics we are looking at it again, GPU count, GPU memory, right? They never take into account, exactly GPU type. So precisely, it's like how powerful, what is what is capability of the GPU? Is it a high-end one, low-end one, good one, bad one? So and expertise can tell that from the SKU name. So we know A800 is better than A100, but in customers they probably don't understand. So what is the A100 and A800 for them? Just a number, so it doesn't mean anything about. So if so, we somehow like it's for if to run in the same workloads. So there's no point to customer easily to specify. Okay, I want to get better performance. What type of GPU I need to use? I want to get a little bit lower performance but cheaper. What kind of GPU I want to use? So this kind of information in terms of the performance capability of the GPU is not. I mean, it is not a model at all. So in my opinion, so that is something.
Yeah, that's super good, useful input. I mean, we definitely are looking to solve those kind of problems. Both of those things, one, publishing individual GPU memory, as well as allowing you to specify in a claim. One thing we potentially could implement is I can specify in a claim I need 16 gigs of GPU RAM, and I can specify I need all from one GPU, or I'm okay with you splitting it across GPUs.
Yeah.
If you're okay with it, then your workload has to discover that and do whatever it needs to do to take appropriate action.
So this is actually I think this is a good point, which is a lot of workloads today probably like in this space probably are reasonably good at discovery. But what are this is what is reasonable to expect the workload to discover and what is reasonable to be constrained? Like, I think this gets back to the C group thing, right? Like Linux does have a whole bunch of mechanisms. Cube didn't orchestrate them to start off with, and then we ended up with CPU manager. If the workload today is given 2 GPUs, it sees those 2 GPUs through the NVIDIA drivers or through the other hardware drivers, like TPUs are similar. I don't know about, we should make sure that we're not like saying things that are wrong about like AMD or Intel stuff down the road. But my understanding is that in many cases, there's some input that you need to provide to the command in order to do it. So that's a use case for downward API. I think we need to classify this, which is what is a reasonable expectation for today's workloads to parameterize the command.
Yeah. So Clayton, so you're talking just one. Yeah, one inspection is that you got hardware ready. Then how do you tune your workload to be able to run on that hardware, right? That's one dimension of the problem.
The hardware you're given, yeah. And that's the stage lower. But I just want to highlight too, like if a workload's pretty flexible to the hardware it's given, that's kind of a different scenario than if the workload is very inflexible to the hardware it's given.
Yes.
And that was, I was going to actually you brought up. We should be clear that we're separating out what a platform admin does and a workload author. Like those are just the 2 groups that I'm picking. Okay. But if we want to argue about those, but like workload authors today are actually in close conversation with platform admins, or they're the same person when they set up hardware, because there's only 3 types or 4 types of hardware in practice. There's a small set of choices.
Yes.
But then as the number and range of topologies increases, which is kind of what we're talking about here, right? Like there's 3 generations of accelerator that are relevant for LLMs today. Next year, there'll be 5, or maybe like 3 or 4 classes. As that number grows, we should probably be providing inputs to DRA that help scope those numbers, I think, and what we expect the workload authors to want to switch between. So like, if I'm a data scientist, I'm probably like, I might know which ones I need, but somebody had to expose those to me. And so the argument might be, if the platform admin is still the one who's responsible for exposing it, then maybe the mechanism doesn't have to be baked into his cube. We just want it to be standardized so that many workload platforms can view it consistently. So I think we need to capture some of this. Like it's not, like John, is this captured in any of the DRA docs right now, or is this fruitful for us to spend time on as a group?
I think we don't talk about any of the workload discovery aspect. I mean, the downward API thing is just something that hadn't even occurred to me until you said it yesterday. So In some sense, we're washing our hands of responsibility after we make the collection and the allocation, and then the driver itself, like, mounts the devices or whatever it is into the containers, and the workloads have to figure it out on their own.
So
And we can represent.
One point.
Okay,
Can I do a quick time check because we have
Yeah.
more topics on the agenda and
I just want to add a quick point here.
Yeah, absolutely.
So we have, so when you're talking about for a workload to choose different kinds of accelerators, what is the idea behind, let's say, when you have multiple pods or that you want to schedule them in a way that they are running on the same kind of hardware? Is that going to be a requirement that
I think
homogeneity?
And this would be for serving, yes, and for batch, probably. I think that batch has discussed some of the homogeneity stuff. I think from a serving perspective, if I were divvying them up, I'd be like, and maybe this is like another discussion too, is we should have a clear list of representative workloads and can describe it. So like the one I typically think about is like large model inference. If you're doing large model inference and you have 15 replicas, how many scenarios would you want to have heterogeneous hardware under that versus not? And could we make arguments?
Sometimes it's dangerous to use the heterogeneous hardware across the same workload with different pods. You might want
operationally,
to So driver versions and everything will need to be same. I mean those are the kind of things that we probably want to think about when if you're introducing any fungibility in terms of like the hardware that you're trying to do. Yeah.
That's a great point. I'll just say right now, as of what we've had under consideration so far for the 131, 132 time frame, device management is assuming that things higher than pod level, meaning cross-pod constraints, are dictated to us from some higher level orchestrator. So, right, we start at the pod level. We have a claim for a pod that can have fungibility in it or not. If you need consistency across pods, that would be enforced a level up above anything we're considering. I've got requirements and I'm implementing consistency within pods. So you could say something like, I need anywhere from 1 to 4 GPUs, so long as they cover this much memory in aggregate. But if you give me 4, you better give me all the same model. Or if you give me 4, give me all the same model on the same PCI route, right? So I'm hoping to implement that kind of functionality, but that's for a pod. If you need it level up, and this comes back down into the next one around the high performance networks, like that's not I can take a constraint, but I don't have visibility to other pods. So at the layer of that.
And John, you called out something really important. So like, I think Sanjay, to go even further, at some point, most people run out of capacity. And so I think most people are capacity bound on their largest workloads. So we need to, this is like all stuff that we need actually written down as like, there's the classes of workload, like what are you trying to accomplish? There's the scales, and then what are the key concerns for those? So for very large model serving, most people are capacity bound. And so a lot of times I think I over rotate on this. So it's good to, we should have this. When you get to the limit of capacity, your choice is higher latency for the entire workload, or potentially rejecting requests, or accepting non-heterogeneous or accepting heterogeneous hardware. That is a choice that someone has to make through the configuration of their clusters and provisioning, but it is an important choice. Either we need to give the people how to make the choice, or we need to find the things that make that not a painful choice. So like A100 versus H100, odds are you're probably okay. A100 versus 2 XL4s, you might actually want to opt into that. And so I hear, John, you're saying that is this group's responsibility to go think about those use cases, because DRA isn't, and that's awesome, because like I think that gives us a really clear mission. If we don't think about this, it's not going to work. So thank you, Sanjay.
I have a comment.
We had a couple other topics. This is a really important discussion that does touch on those other topics. If we want to spend another few minutes on this, like I think it's okay. But I just want like
just a
sense from the
quick
room.
comment. I think maybe. Yeah, I'm Yuan Chen from NVIDIA as well, and Sanjay's colleague. I just feel right, and so far, I know this topic is mainly focused on the device and from the device management perspective. I just think in general, right, like the use cases, and one particular large model is the multi-node and multi-GPU and inference. Definitely, we have use cases here, right? The large model need to run across multiple nodes, multi-GPU. I just feel, and I look at this list, right? One of the key things missing is from the scheduling perspective. What's the key requirement or change enhancement we need, right? For example, for this and large model, multi-GPU, multi-nodes, and the inference, and we need this topology awareness, right? Like we discussed here, but I'm more talk about we need this hardware device level support. But from the scheduler and the scheduling perspective, what can we do, right? Maybe again, scheduling, port group scheduling, we also need because we have to guarantee within a group of ports and the minimum number of the ports and the inference ports and can be running, right? The second thing is topology awareness, like we discussed here. We have to make sure we place them in the same, right? The networking and the network fabric and the topology and the minimize latency, other thing. So I just want to throw out that from our perspective and our use cases, we think definitely there are some advanced scheduling and or plugin or the mechanism, and we need to manage or schedule this and serving and instance. That might be
So
we can follow up in future.
I added that up above. So that's now captured above the understanding the hardware. And I think we'll go back and rewrite these groups, but I captured that as workload author can ensure that the homogeneity and of hardware and of the network topology is sufficient for the set of pods that are scheduled when they're part of a larger multi-pod.
GAN scheduling, port group scheduling.
So just to be clear, the specific document we're working on, the context is around device management, and that's kind of what I was saying earlier, that at least in this year, like what I want to provide is a model and the data such that we can implement exactly what you're talking about. We provide the data and we provide sort of a composable model across nodes that could do what you're talking about. But I don't have, realistically, scope-wise, in the device management effort, we're not going to be able to deliver anything multi-node, multi-host in scheduler certainly not in this next cycle.
I completely agree. I'm not saying that device management should do that. I just said as part of this working group serving, is this within the scope, right? We probably will be working closely with scheduling, right? That's my point. I'm not saying device driver should do that.
Any use case for multi-host inference is very clearly multi-host, multi-accelerator inference is 100% within the scope of working group serving. Working group serving needs to define the use case, drive requirements to DRA and to scheduling. I added a note at the top, which is to trim non-DRA use cases from this list, given John's feedback. Sergey,
I want to
capture anything else.
I put some milestones here. So I think failures and understanding the hardware, like parts of it, at least we can try to squeeze in 131 and based on John's feedback as well. And multi-host, we need to start discussing it early. So 132 will have something to present. And also we have this this item in the end that we didn't cover, but I want to switch to something else already. It's about modeling like networks and stuff.
So the work stream for 131 should probably dive in on these topics, I think, outside of this meeting. And this is maybe you had this down below, Sergey, but it's how do we organize the work streams so we don't all have to show up together and we can self-separate.
I suggest I'll take this work stream, and Faye and Sanjay, I will reach out to you for feedback so we can have a single document with more details. Okay, let's go back to agenda. We covered this. Clayton, do you want to talk about
So and Faye is here today, and I see Jan's here. We were having a discussion about one of the proposed work streams was what can we do on orchestration? How do we find common orchestration primitives for rollout of inference workloads that would actually support multiple ecosystem things? So Jan and I had a very brief discussion at KubeCon about the serving class construct in kserve is very interesting, but it's not a generic primitive that can be easily extended necessarily. And if I misrepresent anything that we talked about, please correct me. One of the discussions that we've had on the Google side, Abdullah and I've been chatting about, is the idea of having a primitive that's something like a serving class that supports a relatively broad range of use cases. And I think there's some intersection there with work that Kaito has done on presets, which are essentially, an opinionated set of model plus model server. I think NIM as well from NVIDIA in some respects kind of combines that opinionated model plus model server plus configuration. The hope would be to get a set of people together to understand the use cases and the challenges that, for instance, kserve may have with serving classes, and the idea of the model server, model code, and config necessary to run a model could be abstracted in a way that we could bring orchestration to bear kind of across a number of different model servers or topologies. So instance, there's very simple, single replica scale out, but then there's also multi-host scale out, but then there's also disaggregated serving. And then, in theory, a lot of people may want to have a single primitive that they can orchestrate that as it scales, I think aspirationally, as you scale a workload and it needs more and more load, it would be nice if, and it may be nice but not possible, if there is a set of primitives in the Kube ecosystem that could support that changing topology or abstract it, but allow pretty rich extensibility. So the point of the orchestration workstream would be to gather these requirements, to have some of those discussions, to talk about model rollout. And so I think the first point would be Jan is going to schedule something to kind of go through kserve and introductory and talk about serving use cases, the same discussion we had at KubeCon. Faye, I think I'd like to have a discussion. We've been discussing, but I think have an open discussion on what are some requirements for a primitive for orchestrating, and could we find any common requirements for rollout that would mean that multiple groups could avoid having to support orchestration of upgrades or rollout across multiple components, and then we'll see where it goes from there. So this would be the third work stream alongside auto scaling and the concrete requirements for 1.3.1. And I think it would be.
Yeah, we didn't talk about auto scaling work stream, but yeah, I think this work stream is very interesting, and we need frameworks authors for sure to participate. So all the framework can.
Yeah, we should call that out. Call for participation from frameworks that do inference CRDs or inference use cases on Kubernetes, as well as people who are building their own orchestration frameworks in-house. So I don't know, Janjin, if you have any interest there, or if you have others, of others who would be interested. We'd like to just make sure that if there is the possibility of something relatively common, that we could share it. And if not, maybe we can break it down into, well, there might be some lower level primitives. For instance, Joe Betts from API Machinery, he and I have been discussing the mechanism for making serving or making the class construct in Kubernetes more flexible so that you could actually have typed schemas. Like you could say, I have a serving class and it has these parameters. Could we get to a point where actually that could be part of a CRD so that they could be variable and extensible, but you would still get strong typing, validation, backwards compatibility, version control. So that'll be a thread underneath the the orchestration workstream, which would be requirements driven to Cube that would make writing controllers for workloads better and easier, with a strong focus on this core use case for supporting inference servers. Okay, and yeah, any other comments?
So
Please feel
there is a
free.
good comment about when this meeting can happen. Like, ask to keep this time. So maybe next week, Yuan will explain case, like we can allocate some time.
So my thing would be, I don't want to, I feel like if we're going to have to keep having all the topics in this meeting, we're going to fall apart pretty quick because we're not going to make any progress. So I actually, Carlos, I would really prefer to have a separate
So what about we have
separate
a
meeting,
but then like maybe 10 minutes overview of what we discussed, and maybe
yeah. So every work stream, I think this is maybe like we're talking about work stream structure. I think every work stream should give a quick status update and use the agenda for topics that apply to everybody, kicking off new work streams, or organizational business. That would be my suggestion.
I think a focused discussion would be better.
Okay.
Yeah.
Yuan, do you want to coordinate it and like schedule a meeting?
Yeah, I'll be sending out like an invite maybe today, and let me know if you're interested in participating. Hopefully this will bring a lot of like K-serve folks who've been working in this area for years, and we want to share some of the things we learned, some of the pain points, and some of the challenges we solved along the way.
And that'll actually be awesome, because I do think it's broader than just the orchestration work stream. So the session is about understanding problems that K-serve has that could be moved down into the Cube level. There's the work stream. One of the threads is that we should generate other things and move them to other work streams. And then we did have, I was having some discussions. I think we'd like to try to get Ray here, like from RayServe, the RayServe perspective, to talk about some of their obstacles. So that might be like a third down the road. And Faye, I'd hope that we could continue discussions around gaps that we see from a Kaito perspective. Eduardo?
How could we aggregate in a single place all the work stream meetings, right? Like, instead of like Juan says here, like reach to me to get invited, how could we have like in a Google Doc or some place where people can like, oh, I want to attend this work stream meeting because I have an idea, or I'm interested in the progress of it, right? Instead of trying to look for people in a Slack channels and things like that, how could we better aggregate this? I like that. I feel like instead of putting like reach to me if interested, like we should have a central place where people can just go click and add themselves to an invite.
Well, I think there's the negotiating the time, and then there's adding yourself or catching up afterwards. So there's the three parts. There's awareness, there's scheduling, and then there's discoverability. And I think all of those are important. So yeah, we could start I think on the work stream doc, we might actually want to have like we could probably do like work stream meetings as a separate doc, but we could use the work stream document for now to list those. So I totally agree. Like, we want to get threads going, and we want people to be able to discover the threads if you're in the working group.
Yeah.
Oh yeah, and Abdullah brought up Selden here too as well. I'll make a note of that.
Yeah. Okay. So we just need to announce it in Slack channel that we have, and this document can be used for all the meeting notes. Okay. Next topic. Clay and I move this understanding to org stream as well as the next topic. Just to brief.
Yep.
Then out of it, if you can be brief, and then we can go into like 131 as well, and some organizational questions.
We have a bunch of people listing problems. This is awesome. I really appreciate all the feedback, folks, so far. I think the next step would actually be to maybe give folks a few more, like a day or so more to add and suggest ideas, and then try to turn this into maybe sit down and talk about which of the problems are most impactful, go through the topics one by one and try to do that. So I'll say a work stream call where we talk through and try to say which are the problems that are in scope or not, which ones should be in scope, how do we decide that? So kind of the mechanical process of how we go from a list of ideas into can we get people together to work. So we will follow up on Eduardo's comment there, which is we will announce that in the work stream doc, and I will send an email out and then get something scheduled with the folks who are interested, and I'll add that back.
Do we want to discuss multi-host under the orchestration work stream, or
given that we need to articulate those requirements, maybe maybe we can split the orchestration work stream into two, or we just have, I don't actually know how to organize, the idea of work streams was just, it's better than one group. It was somewhat arbitrary.
I feel that the orchestration, there are two aspects to it. Like there is the building blocks, so it's a bottom up. What are the missing pieces that enables basic functionality? And then there is the top down, which is, okay, how do we simplify the experience and provide something that is more, user friendly, less complicated, and so on and so forth. To me, those are two things that can run in parallel.
Given that multi-host is increasingly concrete, and that we just heard from DRA that they're not focusing on the use cases, so that if anybody's going to focus on it, it's going to be us. I might suggest that we have an orchestration multi-host GPU work stream and run it independent of the orchestration work stream. So maybe we can keep there's like a discovery part of the orchestration work stream, which is talking to frameworks and getting existing experience. And then there's multi-host inference, which is concretely novel. There are concrete things that are going on, and it's a set of distinct challenges, with the outcome being that we wouldn't want in the end for people to have to do two wildly different ways of orchestrating it as the justification for them coming together in the future. Does that make sense?
Yeah, I think so.
Okay.
As an action item here, do we want to create like a document similar to the requirements for the array and requirements for scaling, similar to the auto scaling work stream document? We'll say like multi-host work stream.
Yes, and
requirements there, use cases and whatnot. I'll take that action item.
Okay, I'll assign that to you. Awesome.
For the multi-host workstream, I do think that we should name it not multi-host GPU, but multi-host accelerators. Yeah, because I feel that GPU cuts down the networking part, right? Like when doing multi-host, we also care about like super connects, right? Like I was going to say NVLink, but as network accelerators. So yeah.
Yeah, and I mean, like from a Google perspective, we care about this from TPU perspective. So I don't think you have to worry about Abdullah forgetting about that. And we actually, so as a principle of community here, this is going to be a very, we're all technical people. We all have employers. Like nobody on the TPU team tells me what to do, but I am incentivized to go work with both the TPU team and the GPU teams. And maybe in the future, I'll be working with all of the accelerator teams. I do think actually as this group, we should try to use accelerator when we're talking generally, but our job is to expose what people who are using Kubernetes now want. And so we are inclusive, but I expect us to have a somewhat GPU focused bent because of the breadth of it. So I think we should, I think we need to, as a group, make sure that all of we can work past any difficulties there, but our end goal is to expose what people are actually concretely doing. And so I appreciate Eduardo that point, and I think we need to I think one thing we can do is work with DRA to actually talk about structural governance, right? Like if we feel that if we're being too generic or if we're being too specific, that people should have an outlet for that. And I would say the working group generally, that would be something we would bring to SIG Arch in Kubernetes. Like we've had some of those discussions with storage and networking in the past or between cloud vendors. So just as a general point, if anybody's concerned about that, reach out to me directly. And we'll try to figure out, is there anything we need to add to the charter or Kubernetes? I'm not worried about it. I haven't seen any signs of it happening, but I know everybody likes to dance around it, and I like just to be upfront. We're gonna go do all accelerators, but we're gonna focus on the one people are using.
Yeah, for sure. No, I agree with that part, but I was also going for like when talking multi-host and just talking about like the node level stuff, we should not forget about like networking, right? Like that's an important part of it. So that I was more going for like the network drivers than the second part, but yeah, I agree it's important.
Yeah, I that was more of a random tangent for me, but
yeah, basically we call it a distributed inference as a term. Yeah.
Okay,
I
we
guess
have 5
maybe
minutes
just
left.
call it multi-device inference. Yeah, let's capture everything.
We only have a few minutes left. I just wanted to highlight that for 131, we will have we only have limited time for 131, and so far what I see we can do is improve error handling and claims priorities like defined for 131 DRA, and we may want to invest into some startup improvements and startup improvements, like more ideas for in this auto-scaling working group as well. Yeah, startup is slow is like significant pain points for inference. So if like I'm looking for a way to prioritize like what exactly is the biggest pain point out of all those pain points, because we cannot take all of them. So I heard that like on a Slack somebody mentioned Matis, right? So Matis should be on the call. Something about startup probes, sub-second startup probes. I haven't heard it as a biggest pain point, but I can believe it can be. So
what about first-class support for preloading images? I mean, right now we have pinned images, but it's still kind of working against the kubelet.
Yeah.
Okay. That's an interesting point. So I was going to suggest that we talk about this in the auto-scaling stream, and we can rename it because auto-scaling is kind of the dual of fast startup. You don't auto-scale if startup's really slow. So anything we do to improve auto-scaling on the biggest stuff requires some improvements. But if folks don't like the name or the grouping, maybe that'll be a topic for this week, or in that first meeting of the auto-scaling group. We look for things to pull out and suggest for the work stream. So please add, if you have suggestions of improvements you would like in 131 that are auto-scaling or startup specific, add them to the auto-scaling doc, and then we will transition them into the 131 suggestions and call them out in the auto-scaling doc as something you think we could, or we can generate a list of things we think we could accelerate.
Okay. Clayton, you said that you want meetings for the scaling group this week. Do you want to schedule it, or we want some other chair of this group to help?
If there's somebody who wants to help chair some of these the work streams, I would absolutely love it to be a vocal contributor rather than organizing.
I think we can divide and conquer. We have 3 chairs, and as far as I see, we have 3 working streams. So sounds like a divide and conquer solution.
Okay. I will take this one. Yuan, probably orchestration. Okay.
I can take the startup acceleration, the auto scaling work stream. But yeah, I'm using that Brunel is here, and Maciek is not here. I think I heard he was just on the chat. Like, what does Signo think about the faster startup? Like, how do we differentiate from the kubelet and then the container runtime itself, right? Because we might have different speeds, like a startup speeds when doing containerd, when doing Docker, like, how do you differentiate this when working from the Kubernetes ecosystem, like a Kubernetes working group, when we have like a possibility of having multiple runtimes?
So I think like there are things outside of the runtime, right? Like evented plague is one, the sub-second probes are another one, preloading images is another one where it could have an impact irrespective of how the runtimes individually implement those features.
That raises also a good point. I think the job of serving is to have a set of key workloads and then to kind of that we're focused on improving, and then to have a broad set that we would like to benefit, right? And we're always going to have to balance that. I think it would be a mistake to say we're only going to do things that improve all cube. And I think that's a charter / just practically speaking, we've been doing cube a certain way for 10 years, and we haven't made a ton of progress on some areas that if we'd had more focus or somebody who actually was advocating for a specific use case, like stateful and operators are actually maybe the two example I would point out of. There's a lot more we could have done that just struggled. So maybe this is it's the role of the working group to surface the general improvements and then to ask whether we can accelerate them generally if we have to gather use cases. But I guess maybe another question, Mernal, would be do you think that SIG-Node is the one who would prioritize startup improvements, or do you think serving should be,
I think serving can suggest what will have the most impact, right? From these items. Is sub-second gonna matter if the problem is image pull is taking 5 minutes, right? Is evented gonna matter if the saving there is a fraction of a second if you're still pulling images? So I think if serving can give us a list of, okay, this is gonna have the most impact, we can prioritize that in that order.
Yeah, I see it the same way. So last topic on agenda, sorry for getting into that. But Jackson also suggested to help with TLing this, sharing this group, and we also have multi-host work stream coming up. I strongly suggest to add Jackson as well. Jackson. Any objections?
Yeah, I think right. Yeah, currently because I'm working on the infrastructure in ByteDance, we like to bring our robust end user perspective to working group serving, and yeah, I'm working on different open source projects. I think yeah, I can help on the technical side for sure. Yeah.
Yeah. If there are objections, please speak up now. Otherwise, I will go ahead and send a PR adding Jackson, and maybe next time we can get you to help with workstream multi-host or some other workstream. Thank you very much. Okay, I don't hear any objections. With that, let's finish the meeting. We a little bit over time. Thank you, everybody. Bye.
Thanks.
Thank you. Have a good day.
Thank you. Bye-bye.